Good evening. Today is Tuesday, February the 2nd. Today in pre-calculus, we looked at the ellipses again, and in this case, we looked at a concept called the eccentricity. So I will share my screen and show you some of the types of problems we looked at today. So when you look at an ellipse, what we looked at today, if you look eccentricity, we'll get eccentricity, which is E, is defined to be the ratio of C over A. Now, if you remember from yesterday, when we look at the ellipse, the C is the distance from the center to the focus, and A is the distance from the center along the major axis to the vertex. So if we look, for instance, let's say if we have a situation, let's say where our vertices, so let's say our vertices on our major axis are, let's say we have 10 and 4, and we have minus 6 and 4. And we say that our eccentricity is 0.8. So let's say eccentricity is 0.5. All right, now eccentricity, if you'll notice, if the eccentricity equals 0, the eccentricity equals 0, we have a circle. If the eccentricity is between 0 and 1, so if it's less than 1 and greater than 0, then we have an ellipse. Eccentricity of 1 is a parabola, and then we go to the hyperbola for eccentricity greater than 1. So if I look here at my graph, see when I'm drawing the graph here, so I've got my axis, here's my y-axis, and here's my x-axis. So now I say, see my vertices are at 10 and 4, so I come over here. This looks to be about like 10 and 4, somewhere about right there. That would be 10 and 4. And so that's a little dot right there. And then I come over here to minus 6 and 4, somewhere about right here. Minus 6 and 4. Now, so that's my major axis. Now, the major axis then is 16 across. So half of that would be where my center is located. So if I take the average of 10 and minus 6, that would be 2. So my center here is at 2 and 4. So that means A is 8. So I come over here. So A is 8. So then I can tell, okay, so my eccentricity is 5. My eccentricity 5, that means C is 4 because 0.5 times 8 is 4. So now I know then that my foci are at, if I add 4 to 2, I get here to 6. So this would be 6. So there's one of my focuses. That's F1, we'll say, at 6 and 4. And the other F2 here is at minus 2 minus 2 and 4. Okay, now, so when I draw my, or write my equation for my ellipse, I can basically start with a standard here. I know I've got an x here with a square plus a y with a square equals 1. And I can divide this by now. So if I look, my major axis is along my x-axis, the distance from the center here, which is 2, to the right vertex is 8. So I square 8, so I know this right here is going to be 64. And then the difference between these two numbers here is c squared. So if I square 4, I get 16. So that would mean that this right here would be 48, which is my minor axis. And then, of course, my center is at 2 and 4, so that would be a minus 2 here, and that would be a minus 4 here. So that's the type of work we did today. We went backwards to find the equation given certain pieces of information. So I'm going to stop sharing here. If you have questions, if I can find my cursor, here it is. Okay, if you have questions, as always, send me an email. Let me know where your problems are. And if you look and see on Thursday, tomorrow we'll be looking at hyperbolas. On Thursday, we'll be looking at the Chapter 7 mid-chapter quiz. So you can work that and send it in to me. I will put the Chapter 7 syllabus on the OneNote here tonight, I think, if I can do that. Otherwise, I will send it to you in an email. So if you have any questions, get to me, and I'll get back to you. Thank you.